Good day, people. Welcome to the last lesson on conversions. Before we go on to the next topic, I am referring to this document yesterday here. That's the same document where we were. We've done it yesterday, the day before. We stopped there, and I'm going to say we're going to look at this here. And as I said before yesterday, this is actually where we really want to be. And as I said yesterday also, when I say this, then people say, okay, now the first 6 pages I'll ignore because I don't need to know that. I'm going to know. By the time you get here, you need to have done all 6 pages, work through all of them before you get here. Okay. A lot of students think they know it all, but they don't actually know it all like they're supposed to. Okay. Right, people, from this year, we're going to do mainly area conversions. Volume, that's an area conversion, that is a volume conversion, and that's another special one we shall just talk about, meters to the fourth, and we'll do a few special cases as well. Okay, let's go to my board. Right, let's do some volume conversions. Right, unless, for example, let's say I want to convert, let's say 12.67 meters squared. And I'll answer it. The question is converted to millimeters squared. Okay. Now, people, as I did mention yesterday, this is a two-step operation. If you remember the 2 steps and you follow those 2 steps properly, you can convert almost anything to anything. Well, you can't convert rands to gold, but you know what I mean? But you can convert really almost anything to anything, right? First step is, okay, just imagine, take the square away, okay, and convert meters to millimeters. Okay, so you first convert the base dimensions. Now, if we go to the base dimensions, if I go to the top there, okay, you first convert meters to millimeters. Is it multiply or divide? Okay, if we go into the right, it is multiply. Multiply by how many? By 1, 2, 3 places. So that means we're going to multiply by 1,000. So that there is 12.67 multiplied by 1,000, okay, but it is area. I'm going to put it back. So, okay, so we square that, okay, and that is now becomes millimeters squared. So people, that's actually the conversion done. I'll say it again. We convert meters to millimeters, which is times 1,000, but it's squared because it's area, and the rest we just tied it up. So I'm going to say that's 12.67, okay, and you will agree that 1,000 there is 10 cubed, okay, squared, millimeter squared. I'm doing it the long way for the first time, so if I tie that up even further, 10 cubed squared is 12.67 times 10 to the power 6 millimeters squared. There we go, and that's it. Okay, so 12.67 meters squared is equal to 12.67 times 10 to the power 6 millimeters squared. Or if you're feeling really smart, you can remove all the decimals. Okay, you can say it's 12.670 millimeters squared. Okay, the decimal was sitting there, so it's 1, 2, 3, 4, 5, 6. Another decimal point is sitting there. So that is equal to that, is also equal to that. But because we engineers, we won't write it like this, really, because that's too long. We'll stop there. That will be just fine. Okay. If you want to write it like that as well, that will be correct. If you got a decimal there, it will be wrong. If you have another note, that will be wrong as well. Okay. So 12.67 square meters is equal to 12.67 times 10 to the power 6 millimeters squared. I'll say it again. First, convert the base units to each other by multiplying or dividing, but in this case, it's going from a big to a small. So we multiply by 1,000 squared because it's area. Okay, so that is how we convert that one there. Okay, let me clean the board and we go to the next example. Sorry, people, I just checked. Did I have millimeter squared there? It should have been millimeter squared. My apologies. Okay, millimeter squared. Right, the next one there, number 2. Let's go number 2. We must convert 12.67 cubic meters to cubic millimeters. Right, so what's the first thing we do? We convert the base units to each other. We convert first the meters to the millimeters, and that is, as we all know, it's multiplied by 1,000. So it's 12.67 times, and you will agree now that 1000 is the same as 10 cubed. So it's times 1000. Okay. But it is volume, so we cube it. So that becomes millimeters cubed. And if I tidy that up, that means if I remove the brackets, it becomes 12.67 times 10 to the power. Right. It's not 6 or whatever, it is 9 millimeters cubed. There we go. Okay, so 12.67 cubic meters is equal to 12.67 times 10 to the power 9 cubic millimeters. Okay, right. Clean the board, and we're going to do the next example. Right, we need to convert 186.847 cubic centimeters to cubic meters. Okay, so it's a two-step operation. What's the first step? We need to convert the bases to each other. So if I just for the moment just take that away, and I take that away like so, okay, I'm only looking at centimeter to cubic meters. Okay, so do I divide or multiply? We must divide because we're going from a small to a big unit, right? So I'm going to say it is 186.847, and I'm going to multiply by, is that divide or multiply? It is divide by what? Divide by what? I'm going back to my table there. I must convert from centi to meter, so I'm going left, so it is divide by 1, 2, so it's divide by 100, okay? So divide by 100, which is the same as 10 squared, okay? So I can either divide by 100 or multiply by 10 to the power minus 2, okay? I can either divide by 10 squared or multiply by 10 to the power minus 2, but it is cubed. It's a volume. I'm writing it back in there. Maybe I should just make it nice again, okay? So it is, oh sorry, it is cubed. That will give us meter squared, okay? And now you tidy it up like we're supposed to do algebraically. That will be equal to 186.847 times 10 to the power minus 6 meters squared. There we go. Okay. So 186.847 cubic centimeters is equal to 186.847 times 10 to the power minus, sorry, you should have told me. My apologies. Okay, I'll say that again. 186.847 cubic centimeters is equal to 186.847 times 10 to the power minus 6 cubic meters. Okay, so that is how we convert that. Right, let's clean the board and look at the next one. Alright people, if I go to my table, I'm in my worksheet. If I go down there, right, that's there, we've done that. Right, so you can do 1, 2, 4, all of that there. Okay, you can do all of that there. There's some engineering notation examples you need to do. Let's look at this one here, number 3. It says convert 4.236 cubic meters to millimeters to the fourth. Okay, now what is millimeter to the fourth? Now people, if we have a straight dimension, we measure it, it is so many meters or centimeters or millimeters. Let's say meters. If we have a room size, okay, if we have a room size, let's say we're measuring the floor of a room, it's a rectangular room, that's 4 meters, and that's 3 meters, okay, and the area there is equal to 4 times 3 is equal to 12 meters square, okay, so that's area, okay, and if I have, let's say the room looks like this, like that over there, that's 4 meters there, that's 3 meters there, and that's the room is 2 meters high, or the box. Then the volume is, so the volume is 4 times 3, which is 12 times 2, so the volume there is 24 cubic meters. Okay, if you leave the unit out, I take off 2 marks for that. You know why. Okay, so the area is 12 square meters, the volume is 24 cubic meters. But where does meters to the fourth coming. That concept there, I'm not gonna say much about it. We call that second moment of area. Okay, second moment of area. Okay, and it is either measured in meters to the fourth, or is measured in millimeters to the fourth, or is measured in centimeters to the fourth. Okay, now often when you get to structural steel tables, maybe I'll try and pull up one for you quickly, just show you quickly. Just let me pull up a steel table for you. People, they have pulled up a steel table for you. Okay, steel tables means just if I zoom in slightly, okay, you can see that's an I section because it looks like the letter I. Okay, and you can see structural steel tables. I mean, if you're a steel designer, this will be almost like your Bible. You work from this. Okay, you can see B, H, HW, TW, R1, and TF are all dimensions. So if we're looking at this particular size here, it's called an IP100. There's its mass. That's its H dimension. Okay. Oh, what am I doing? That's its H dimension there. Okay. And that's its B dimension. What we call that there. We call that there. Sorry, let me just, I think I did something naughty. Let me just take this away. Just give me a second. Just give me a second here. There we go. I just clicked some wrong and it just went all nuts. Okay, we're back to where we were. Right, so there's an I section, and for example, there's a list of sections. There's all their names, but if we take the first one here, because it's close to the sketch, the mass of that, so the height of this particular section H is 97.6 millimeters from there to there. The width of the section little b is 55. And TW is the thickness of the web. We call that vertical piece the web is 3.6 millimeters. And that bit at the top and the bottom is the thickness of the flange is 4.5. And the radius inside there is 7 millimeters, and so on and so on. And the cross-section area is 0.856, notice there, times 10 to the power 3 millimeters squared. Or if I multiply that all out, the cross-section area for that section there is 856 millimeters squared. Okay, and I want to come to this. So there's a second moment of area. It says IXX, that's a capital I, and I is the shortened, that's the abbreviation for second moment of area. So it's all of that there. So capital I, we read it as second moment of area. One letter, but lots of words attached to it. And you can see there, the second moment of area for this first section here is 1.36 times 10 to the power 6 millimeters to the fourth. That is why we need to know that. Now, if you're using another set of steel tables from another manufacturer or another company, they will have that in centimeters to the fourth. And if we're doing calculation in class, most probably we'll have to convert it to meters to the fourth. That is why we are learning why we need to convert between meters to the fourth, centimeters to the fourth, and millimeters to the fourth. Okay, right, let me clean my board quickly and we'll do a quick conversion and see how we do that there. Okay, people, I'm going back to my exercise. I'm soon going to do number 3 because I'm feeling in a good mood. Okay, so let's do number 3. 4.236 meters to the fourth. Right, let's see. It's going to be a number 4 now. Although it's number 3 in the page, it's going to be a number 4. 4.236. Is it meters to the fourth? Yep, we must convert it to millimeters to the fourth. Meters to the fourth is equal to millimeters to the fourth. There we go. Right. And people, the two-step process is exactly the same. So what's the first thing we do? We convert meters to millimeters. Is it times or divide? It is times, because you're going from a big to a small unit. And it is times what? It is times 1,000. And it is 1,000 the same as 10 cubed. But it's to the power 4. So that's going to be 4.236 times 1,000. But because it's second moment of area, it's to the fourth. And it will be millimeters to the fourth. The conversion is done, and all we just do the algebraic tidying up. So it's 4.236 times 10 to the power, you got it, 10 to the power 12 millimeters to the fourth. That's it. Okay, so 4.236 meters to the fourth is equal to 4.236 times 10 to the power 12 millimeter to the fourth. Okay, so number 3 is done. Isn't it lovely? Yeah, this is great. When I'm in a good mood, then I do it all for you. I'm only joking. Right, people? There's number 4 and number 5, so you can continue to all of that. There's engineering notation. There's that there. Right. Now notice we get to some things here. We get to some special things over here. Right. Now, I'm going to look at this one over here and just explain a few things. Right. Let me just stop. Right, people? That's a beam. We show a beam when we get to beams later on in the semester. There's a beam over there. We draw it as a line, even though it's got thickness and height and width, but we show it like that there. And there's supports. Supports could be a column. The column could be circular, it could be square, it could be even an H section like I showed you earlier. The column could even be something like so, like that over there. Okay, something like so. But I want to just talk about the loads. There's a load acting at the point there. We call that the point load or concentrated load. I'll talk about that more when we get there. This load here is what we call a uniformly distributed load. Okay, notice there it has a weight per meter. That means for every meter run, like as in run, the word run. For every meter run, it weighs 10 kilonewtons. Okay, this one is acting at that point there of 42 kilonewtons. And notice people, that unit of measurement and that one there is not the same. Can you see that? It's different things. We're not making cake. Okay, we're not throwing a bit of raisins in here, a bit of flour in there, but no, we're not guessing. It's exact. Okay, we're doing engineering. UDL is kilonewtons per meter, or this is also the same thing. Okay, newtons. Okay, that is the same as that there, but just as kilo. What is the K? Yes, you remember, don't you? It's a sub-multiple prefix, so it can either be newtons per meter or it can be just newtons. Okay, so that there is a concentrated load, and that is a uniformly, maybe I should just write it, uniformly distributed load. I'll just write it here, distributed. Oh, it's a long word. Even I struggled to remember it. It took me 30 years to remember it, and I remember from this onwards. Okay, yes, it took me 30 years. It should take you 1 second. You're very smart. Alright, and of course, because we're lazy human beings, we love acronyms. We call it a UDL for short. Okay, so that's a point load or a concentrated load. That's a UDL, right? UDL is measured in newtons per meter or kilonewtons per meter. Right, I'll go back to my page, not that one there. So that there is a UDL. That's a UDL and that's a UDL. Why? It is a force divided by a distance. Right. The question there says convert newtons per meter to kilonewtons per meter, and it says convert kilonewtons per meter to newtons per millimeter. Right. Now, I'm going to do some examples quickly there. Let's call this number 5. Let's make it blue. Let's call it number 5. We must convert, say, 168.42 kilonewtons per meter to, let's say, what's the conversion there? To newtons per meter. I'm doing an example like by number 11 there. To newtons per meter. Now this here, I can write the same as 168.42 kilonewtons. No? So that line is the same as divided by meter, and in front of the meter I've got a 1. Okay, so this here is the same as that, but we don't write this like that. We write it as 168.42 kilonewtons per meter. Per means divide. Right. Now we must convert this to newtons per meters. Okay, what does it mean? It means that the stop line we need to convert, the bottom here stays the same. So what's kilonewtons to newtons? Is that divide or multiply? Yes. Are we going to a big unit to a small unit? we're going from a big unit to a small unit. And if I go back to my sub-multiple prefix table, which is on page 2 of this document here, yes, it's 1,000 of, okay? You should know this by now. I'm assuming that you know it, okay? So we need to multiply by 1,000. So it's 168.42. So kilo to Newton is times 1,000, okay? And that will be give me newtons over meter. So that's the same as I can either write it as 168.42 times 10 cubed newtons per meter, or I can say it is, let me just make it smaller, and just move it for you, so I'll give you some space. So I can either write that as 168.42 times 10 to the power 3 newtons per meter, or if you want to, you can write it as 168. You can multiply it out, so it's 1, 2, 3. So 168.42 kilonewtons per meter is equal to 168.42 times 10 to the power 3 newtons per meter, or 168,420 newtons per meter. That is equal to that, or it's equal to that. So that is how you do that one. Okay. I'm looking at the next one. Oh, sorry, the next one is over here. Where am I? Oh, it's down the page. I'm going down the page, There we go. Okay. Right. Here we need to convert newtons per meter to kilonewtons per meter. I'm going to leave it up to you. Okay. Right. Okay. There we need to convert kilonewtons per meter to newtons per millimeter. Notice here, we need to convert the kilonewtons to newtons, and we need to convert the meters to the millimeters. Be careful. Right. That I'll talk about later. Right. We need to convert newtons to millimeters squared and kilonewtons to millimeters squared. Okay. We got newtons over that, kilonewtons over that. Okay. So you're going to have to think about that there. Right. Kilopascal and Pascal and all of that. I'll do some of that right now quickly. Right, let's see. Let me clean the board and then we'll do the next one. Now people, now if I go down to the next page, I'll talk about it in a second. And the last page there, yippee, that's the last page. Okay, the last page there, I've got, I just call it special cases. Okay, now special cases, I'm going to talk about that one now. Okay, that one over there. So let's talk about that one there. I don't know what number are we. We're on number, I think number 6. If I get the number wrong too much, so long as we just do them. Right. Pascal, okay, is the same as newtons per square meter. Okay. What's newtons? That's force. That is area. Okay. So that's force over area. Now remember, we spoke about force over area in our very first page on this page when we spoke about Greek letters and the meaning. If you cast your mind back, if you remember, I think it is stress. Yes, stress is force over area. I'm going to go back there and see if we are correct. I'm going to go back to the first page. I'm going back to the first page. There we go. Stress. There we go. It's force over area, newtons per square meter. Very, very important instructions. And what did I say when I spoke about this yesterday or the day before in the first lesson? Force over area, stress, newtons per square meter, goes from now until your final year instructions. You need to know what it's about. Okay, right. So stress is equal to force over area. It is newtons per square meter or newtons per square millimeter, depending on which area we're using. We can either use meter squared or millimeter squared. But if you're using newtons per meter squared, the combined name for that unit there is also called the Pascal. Its full word is written like that. Now often, by the way, when we have a unit written with a capital letter, it is named after somebody. Pascal was a person. Remember James Watt? James Watt. The guy who invented energy, we name Watt after him. Okay, and so is Celsius and Fahrenheit, etc. If we have a unit with a capital letter, often, not all the time, It's named after somebody who invented it many, many years ago, who has passed on into the next life, who is hopefully sitting in heaven and looking down at us and say, oh, they are still using my units of measurement. They are very clever people. We just use it. We thank them for it. Okay. So, and the abbreviation for Pascal is PA. If you write P, it's wrong. It means something else. It's PA. So the combined name for newtons per square meter is Pascal. Okay, so Pascal is equal to newtons per square meter. Okay, so that there, where am I? I go down to my last page there. And scroll, keep scrolling. I don't want to go too fast. Otherwise, eyes go all screwy up. So Pascal, so 1 Pascal is equal to 1 Newton per square meter. Okay, right, so that's that over there. Now, the top one there, megapascal and newtons per millimeter squared. Right, let me just draw a little line here. Maybe I should just clean this off. Now, I'll draw a line here. Let me draw a line here. Okay, make it a layer there. Right. Megapascal is equal to, what does mega mean? It means a million of. Submultiple prefix, you must know this now. Okay. What is Pascal? Okay. So megapascal just means a million pascals. What is Pascal? Pascal is newtons per meter squared. Okay. Right. That's 10 to the power 6 newtons over. Right. I need to convert meter squared to millimeter squared. Now remember we spoke about earlier, is this time we first convert the base unit to each other. So what's meters to millimeters? It's times 1,000. It's times 10 cubed. But it's squared because it's area. So it's times 10 to the power 6. There we go. So 1 meter squared is equal to 1 times 10 to the power 6 millimeters squared. Oh, and algebraically, cancel that, cancel that. It's equal to 1. So that there is equal to newtons per millimeter squared. Sorry about that. Newton per millimeter squared. So what am I saying? So therefore, okay, therefore, 1 megapascal is equal to 1 Newton per millimeter squared. What am I saying? I'm saying that 24.86 newtons per millimeter squared is equal to 24.86 megapascal. 25.789 megapascal is equal to 25.789 Newton per millimeter squared. Are you getting me? So one of that is exactly equal to one of that. So 20 megapascal is equal to 20 Newton per millimeter squared. That's a unique case. Okay. So megapascal is equal to Newton per millimeter squared. And you know, I often ask it in an exam, and when it comes up, people work it out and they give me another answer. It's the same thing and they get it wrong. Okay. So that there is a special case. So that's a special case. Right. And some of them I'm just going to talk about. Let me just see here. Let me just see. Yeah, call up the pen here. Right. 1 ton. Okay. 1,000 kilogram is equal to 1 ton. Okay. 1,000 of that is sitting inside there. Okay. Right. We did area conversions. Yippee. We did volume conversions. There's a question there. What is mass and what is volume? Think about it. What is mass and what is volume? Is it the same thing? Is it the same thing? No, it's not the same thing. Go and look it up, because I could just ask it in exam, explain mass, explain volume. Okay, the one is in kilograms and the one is in meters cubed or centimeters cubed, so they can't be the same thing. So go look it up and go see what its definitions are. Right, we've done area conversions, we've done volume conversions. Right, cubic centimeter to liters, okay? 1 liter is equal to 1,000 cubic centimeters. Okay, make a note somewhere. I'm not going to explain this. You need to learn this and remember that. Okay, 1 liter is equal to 1,000 cubic centimeters. So 2 liters is equal to 2,000 cubic centimeters, and so on and so on. Okay, and you might or might not know, when before many years ago, before you were born, when I was a kid your age, we call this the imperial system of measurement, and we call this the metric system of measurement, which is actually French. Okay, so to convert from imperial 1 inch to metric, so 1 inch to millimeters is you multiply by 24 millimeters. 2 inches you multiply by 24. So to convert from inches to millimeters, you multiply by 25.4. Okay, and that is that conversion there. You must know it. Often when you pick up a plan in site surveying, okay, you pick up a plan that's been drawn, let's say 30 years ago, it's in feet and inches in imperial, you need to convert it to that. That is the basic conversion. Okay, right, 1 liter, I made a mistake here, that's wrong there. 1 liter is equal to 1,000 cubic meters. Okay. Or did I make, I think I got that the wrong way around. Just give me a second. Let me just pause it there. I think I got that the wrong way around. Yep, I got it the wrong way around. Make a note. Okay. I'll write it at the bottom here. 1 cubic meter. Oh, this doesn't like this thing. I can change it over there. 1 cubic meter. Sorry, 1 cubic meter, so 3 is equal to 1,000 liters. Okay, make a note there somewhere. Okay, let me just get this correct rather before we get it wrong. Right, there we go. Okay, 1,000 liters is equal to 1 cubic meter, and 1 liter is equal to 1,000 cubic centimeters. Okay, make a note, learn them, because if they come up, you know what they are. There's a temperature conversion there. I'm not going to say much about this. Temperature conversion, to convert from degrees Fahrenheit to degrees Celsius. You take the degrees Celsius value, you multiply by 9/5 and you add 32. Okay. If you didn't know, you might have to use a conversion one sometime soon. To convert from degrees Fahrenheit to degrees Celsius, you take the value in degrees Celsius, you multiply it by 9/5 and you add 32. Okay. If you're converting the other way, if you're converting from Celsius to degree Fahrenheit, you take the degree Fahrenheit conversion, you minus 32 and you multiply it by 5/9. You do the inverse. That's all I want to say there. Right, radians to degrees. That just comes up often. I'll do a quick on our board there. Let me go back to the board. Let me clean the board quickly. Let me pause and clean the board, and I'll do that, and then we'll almost be done. Right, radians to degrees, vice versa, and define radian. Right, some of you might have heard radian, but I think most of you will not have heard of what a radian is. Right, let's say I have a circle. There's a circle, and there's its vertical line, and there's its horizontal line. Okay. Right, let me just see. Right, that there is its radius, and of course that's also a radius. Okay, and the angle inside there, let's call it the famous theta. Okay, and if I measure that arc length over there, yes, the curve length, we call that S. Okay, so if I take any circle, okay, and I hold these two radii at such an angle there, okay, so that angle there, is equal to hang on, let me just redo my sketch. Just give me a second. Now I think my sketch is okay. Alright, people, let me just start again. There's a circle there. There's this x and y axis, let's call it, and there's it, and there's just two radii. Okay. Now, if those two radii are held at such an angle theta, such that arc length there is, okay, is equal to a radius, h is equal to r, then that angle there is defined as 1 radian. Okay, and the formula S there is equal to theta multiplied by r. Okay, so I'll say it again. So if we have any circle, no matter what its dimensions are, okay, and we have two radii held apart at such an angle so that the arc length S is equal to the radius of that circle, then the angle inside there is defined as 1 radian. It's an N there, okay, and the formula for that arc length there is equal to the angle times r, and that angle there is measured in radians. And radians, people, is just a circular form of measure often used in engineering. Okay, we've been using degrees all along in school, and you'll be using degrees a lot of the way in your studies from here onward, but angles are also often in engineering measured in radians. Okay, and yeah, so that's in, and now often when let's say you have to use an angle in radians, okay, you have to convert from radians to degrees, from degrees to radians. So to convert from degrees to radians, okay, you take your angle in degrees and you multiply it by 1. Let me see, you multiply it by pi over 180. Okay, if you have an angle that you need to convert from radians, radians for short, to degrees, you take your angle in radians and you multiply that by the inverse, by 180 over pi. Okay, and that will be degrees. That will be in radians. That's it. Sorry, I'm scribbling. Okay, so if you have any angle in degrees and you want to convert it to radians, you multiply that angle by pi over 180. Okay, if you have any angle that's in radians and you need to convert it to degrees, you multiply it by 180 over pi, the inverse operation. Okay, people, so that's my note on special cases. Okay, that's the same as other. There's a conversion for that. I spoke about that over there. And if I'm going up over there, let me just clear this here. I'm going up. But look at this one here. Okay, number 14. Convert megapascal to kilopascal to gigapascal. When you get something like this, the first thing you do, let me see if I can write on here. Let me try to write on here. Alright, the first thing you do is you first convert it to its base unit. Okay, so that there is equal to 56.2364. Oh, that's not going to work. Let me rather write it out. Okay, it's just going to just be a mess. Won't be so nice. And there we go. So it's 56.2364. So that's number 7, I think. Number 7. 56.2364 megapascal. People, the first thing you do is you write the value that's equal to that submultiple prefix there. Okay, so that's going to be 56.2364, and that's mega. So it's times 10 to the 6 Pascal. Okay, right. I want you to convert it to kilopascal. Alright, mega to kilo. Is that from a big unit to a small unit? We're going from a big unit to a small unit. So what do? So we are dividing by 1,000. So that's going to be 56.2364 times 10 to the power, I'm going to do the long way for now. So it's times 10 to the minus 3. So that will be kilopascal. So that's equal to 56.2364 times 10 to the power 3. Oh, sorry, my apologies. Kilopascal. Okay. Right, so 56.2364 megapascal. First write it as its full value. You write the equivalent value there of what mega is. I suggest you do that. Okay. And then you must divide by 1,000 to bring it to kilo. And then it says convert it to gigapascal. Okay. So if I go from here, okay, do I go from a small unit to a big unit? I'm going from a small unit to a bigger unit. So what does it mean? I need to divide by, so that will be 56.2364. I'm starting there again. I'm starting from our base unit times 10 to the power 6 pascal, and I need to divide by 10 to the power 9. So it's times 10 to the power minus 9 gigapascal. Why is it times 10 to the power minus 9? And why is it kilo? Because if I go to the top on page 2 to my sub-multiple prefixes, okay, I'm moving between those over there. Okay, so that's going to be, what's that going to be equal to? It's going to be equal to 56.2364, yes, times 10 to the power minus 3 gigapascal. Okay. And that is how you do that. And so that is how we, oh, sorry, I need to go to my last page. Let's go to the bottom there. I'm going over there. There we go. That is how you do those ones over there. Okay. There it says there. So let's say do that. 210 gigapascal. How do we do that? First, write in the value for giga. So it will be 210 times 10 to the power 9 pascal. And remember, Pascal is newtons per square meters, and then from there you convert to newtons per millimeter squared. There you go. Okay, right. So people, you're now in a position to complete this worksheet here. And as I said the first time, and as I said this morning, the beginning of this lesson, this is the big conversions we use so often in civil engineering. And I've seen students actually don't want to learn it. They don't take the time to grapple with it, and they say, oh, I'll just guess because it hardly comes up. And they guess it wrong almost every single time. In applied mechanics, in TOS, in analysis and design, in third and fourth year. Get it right. Get it right. I'm going to answer it in the first exam. Okay? Right, people, I'm almost done. Right, last activity there. See whether you can do the following SI unit conversion problems. That is out of one of the books I spoke about. Convert this. So the general pattern is here. First there, you can do that. You can do that. Okay. Micro to kilo. First convert micrograms to grams. What is micro? Micro is times 10 to the power minus 6. Okay. And then you convert it to kilo. What's the N? Nanograms to kilo. That's what you do. You first convert it to the base unit, and then you convert it to the unit asked for. Microwatts to watts. That's millinewtons to newtons, megajoules to joules. Okay, and then the last thing there, meters per second to kilometers per hour. I think you know it, but I'll say it again there. Meters per second. Meters per second, to convert meters per second, so you must convert the meters to kilometers, and you must divide it by seconds to hours. Let me see if I can write on it quickly. Tools. Here we go. Okay, right. So if I must convert, let's say 68 kilometers per hour to meters per second. Okay. First thing you do is you need to convert 68 to second. Oh, sorry, man. We need to do that then. Okay, if I write that like that, we can also write it like that, but we never write it like it. We say 68 kilometers per hour. Okay, so I need to convert the kilometers to meters. So that means I take the 68 and I must multiply by 1,000. There we go. Okay, and that gives me the meters. And I need to convert hours to seconds. Why do I do that there? I need to multiply 1 hour. I need to multiply that by, so it's 1 multiplied by 60 times 60. So in effect there, it becomes 68,000 divided by 3,600. Sorry, let me write the units in here. Okay, I'll say that again. This is going to be 68,000 over 3,600, and that will be so many meters per second. And what's that going to be? I'm going to pick up my calculator, and it is going to be 68,000 divided by 3, and it is 18.89. 18.8. Ooh, this is really annoying, this 18.89. There we go. Okay, so 68 kilometers per hour is equal to 18.89 meters per second. So to convert from kilometers per hour to meters per second, we multiply by 1,000 over 3,600. And to convert from meters per second to kilometers per hour, we do the inverse operation. The inverse, the opposite of this. Multiply by 3,600, divide by 1,000. Okay, so people, that is how we do all of that. People, I've worked through all the conversions I can do as worked examples. We've gone down to page 9 in there. I've done all the special cases. You should now be able to work through all these pages there from page 1 up to page 9. And once you see a conversion further on in applied mechanics and in TOS, you should know how to do it, because I'm not going to be teaching it anymore. I'm going to assume that you know it. Okay, people? That's the last of the lesson on conversions. I'm going to stop here. This has been a long lesson. Finish them all. Do them all that I ask you to do. So when things come up in the exams, in the applied mechanics and TOS, and in the year on as you go up, they won't be new to you. You'll know how to do it. Okay? Thanks, people. Thank you for your attention. I'll see you in the next video.